purine degradation. So here you can see the purines AMP and GMP. AMP is an aminopurine with an amide group at the top, and GMP is an oxypurine with oxygen at the sixth position. Now, when AMP is going to be degraded, first it is going to be converted to IMP, and that is through getting rid of this amide group which is present on its top, because when it was synthesized it was converted from IMP to AMP through addition of this amide group by aspartate, which was attached transiently to it, converting it into adenylosuccinate, and then the carbon skeleton was removed and amide group was left behind. Now, when it is going to undergo degradation, first it is going to get rid of this group in the presence of deaminase, and it is going to be converted back to IMP. So here you can see that removal of the amide group forms IMP. Now AMP may also be converted to its nucleoside form directly instead of conversion to IMP. Now, since you can see that we are seeing three nucleotides on the screen: AMP, IMP, and GMP. Now, these are going to be degraded. So, first step would be removal of the phosphate, and since a nucleotide is going to be degraded, the enzyme is going to be nucleotidase. So, you can see 5' nucleotidase. First, we are going to take up AMP and IMP. In the presence of 5' nucleotidase, phosphate is going to be removed. So here you can see that removal of phosphate converts IMP into its nucleoside form, that is the inosine. Likewise, AMP is converted to its nucleoside form adenosine. Now, adenosine cannot be further degraded unless this amide group at the top is removed. So, in the presence of adenosine deaminase, after removal of this group, it is converted to, here you can see that this group is removed and it is converted to inosine. So, the degradation of AMP through adenosine or through IMP merges at this point, which is the formation of inosine. Now, you can see that this is a nucleoside. Now, nucleoside is to be degraded, so the sugar will be removed so that it can be converted to its base form. So you can see that now for the removal of sugar, the enzyme is purine nucleoside phosphorylase. The sugar molecule is removed, and now inosine is converted to its nitrogenous base form, which is hypoxanthine. Now hypoxanthine, in the presence of xanthine oxidase, is going to be converted to xanthine. You can see that an oxygen is added and now it is xanthine. Now xanthine, again in the presence of xanthine oxidase, is going to be converted to uric acid after removal of the double bond present between carbon number 7 and 8. So this double bond is removed and now this is uric acid, which is the end product of purine degradation. Now coming to GMP. GMP, again, this is a nucleotide. It is going to be converted to its nucleoside form in the presence of 5' nucleotidase. So here we can see removal of phosphate leads to the formation of guanosine, which is the nucleoside form. Now we need to remove the sugar. So in the presence of purine nucleoside phosphorylase, sugar is going to be removed and guanosine is converted to guanine. Now guanine in the presence of guanase is going to be converted to xanthine after removal of the amide group. So you can see that the first nucleotides are converted to nucleoside form and the enzyme is 5' nucleotidase. Next, the nucleosides undergo removal of their sugars through purine nucleoside phosphorylase, and AMP and adenosine are converted to inosine, which is converted to xanthine and finally to uric acid, and guanine is also converted to xanthine and finally to the uric acid.